Dear VIP partners, in the following I would like to present you a new tool which is very helpful for a modern advanced patent search and is using semantic search and artificial intelligence ordering. The following description is a general description which is valid for all such softwares which are able to do semantic searches and also to use artificial intelligence for the interpretation of the results. But the examples have been set up using Optimine as one of the software providers doing a good job in semantic search. In the following I would like to explain something about this guide to the semantic search and to similarity patent search. First of all, I would like to give a general description of the search approach. Then I cover the graphical overview of the Optimine features, and afterwards I explain the application of such a tool for semantic search with an example which is taken from the one-to-one support action at the customer of mine who gave the permission to use the results for such purpose. Therefore, I take the example of atmospheric plasma coating and show how to apply the software in that case. In detail, there are following options to do the patent search. First of all, using the semantic capabilities, one can start by entering a longer description of the focus technology, for instance with an available technical description or an abstract of a patent or something like that. Another starting point can be to use already known relevant or very relevant patents by entering the patent numbers into the system. In almost every case, it will then also be necessary to use filters to optimize the search results. For instance, to choose some keywords or to exclude some words which should not appear because they would describe another technology, or for instance to use patent classes. Then there is also the possibility here in this software to do an interactive choice. That means one gets a picture of patent classes of the whole set of all comparable patents, and then also of the specific patents, and one can then choose those classes which are very relevant just for this technique or this technology which is searched here. Another option which is also very helpful is that one can make a cutoff at a certain similarity level. For instance, only use the 50 most similar patents for further considerations. Then I would like to show what patent analytics can do in that case. So we have a lot of options here which can be done to interpret the results, and one very interesting feature and starting point is also the citation analysis which is possible. So in the following, I would like to explain or to give an overview of the semantic search and similarity search. As I said before, one starting point can be to express in plain English the essential and necessary features of a technology, of a product or process of interest. One has to take care that some words, although they may be very relevant, are not enough. One has to take a bit more information in order for the similarity, for the semantic search to be possible. For instance, one can take an advertisement of the special features of the advantages of a certain product or process, or a list of product or device features or process steps which you consider essential to obtain the special advantages of the invention. And then this English text, it has to be an English text, can be input and a search started. And if one sees in the first set of examples something which is already quite near to what you look for, then this is a further good starting point, because by having found such a similar document, you have gained additional vocabulary and expressions to better define your technology and to stress what distinguishes this technology from others. So these differences can then be added to the original list of features in the query. Afterwards, the common features and iterative of this description of the relevant prior art can be copied and pasted, and it is very important that this approach is iteratively done, so you can always improve the search by finding some very relevant documents in the results list and then take them as a starting point or additional starting point for the further search. So Optimine is as this example software. You could also do it clearly with other software which is able to do semantic search. Nowadays, very recent patent search software has this feature of semantic search. But this is the one example of a very successful young German SME who has brought this to a very good level already, Optimine. So Optimine is best started by inserting one or better more than one, which if there are more than one patent numbers, they are separated by commas, and this can then be used as a good starting point for the search. Alternatively, one can also paste the patent description or a technical article describing the technology into the OctiSearch field. If the patent description is not in English, the best way to proceed is to find an English family member or a family member in English language, or one can also use Google Translate or alternatively the patent translate feature of Espacenet, where you can enter a patent number and then you get the translation from practically all relevant languages at least to English, and this is needed here, English translation. So Optimine and all the other semantic search softwares are designed to better handle longer text, because the real important thing how this software works is that the software has, by relying on artificial intelligence, to distinguish which words are quite common also for other inventions, and which words are seemingly very relevant and very specific for a certain invention. And this has to be distinguished by the software. And clearly, this is easier if there are longer texts and more text sources, for instance, by using more than one patent number as a starting point. A first batch of results may often be disappointing, but the goal at this early stage is that you have to find so-called jewels in the result list, so somewhat relevant patent documents, and then by using these patent numbers and input them, one can iterate the search query and enrich the search vocabulary. So on the other hand, a further approach then is to use further restrictions, so-called filters, as it is called in Optimine software. For instance, in this example of atmospheric plasma coating and so on, one can use the two expressions atmospheric and plasma, and that these shall be in the title, abstract, or claims. Furthermore, in this concrete support action for the customer expressed that although atmospheric plasma has also something to do with chemical vapor deposition and physical vapor deposition, these two very common processes where a lot of patents exist are not of relevance for him, and therefore we excluded them by entering these expressions CVD and PVD in the exclusion OR filter. So exclusion OR means that either this or this shall not be contained in the text, the title, abstract, and claims. Further focusing, which is very relevant in most cases, can be made by using the filter for patent classes like international patent class or cooperative patent class CPC. These patent classifications can also be taken interactively from the graphics, which I will show you later. These graphs where you can take them from. This gives a bit of an overview what is possible with such a software. So here it is depicted that on the one hand you get a list always of similar results, and by iteratively improving the results by taking more and more information into consideration or using filters and so on, you finally get a list of highly relevant patents. Then it is also possible to look at the technology's life cycle and to see how the patent families develop over the years, and this can be used as an information whether this technology is still gaining importance or whether it already has reached a plateau or even is losing importance. And then there are also nice graphics about risks and chances of patents. Uh, so on the right you see such a graphic on patent risk, where you can check the patent's economic value and legal risk. Now I would like to show you the concrete approach by using option 1, a longer technical description in English, which is inserted here. I suppose this comes from an abstract. This is a typical length of an abstract, and then you get the list with the 1,000 most similar patents from it. The option 2 is that you can right away start with a relevant patent, or maybe even 2 or 3 relevant patents you know already. In this case, this was a German patent application of one of the companies of the customer, and then this is not enough for the whole search clearly, but it is a good starting point. And it then goes on by showing that when you start the search with this one patent application, you find such a set of basic charts as below. So the chart here is about the applicants. Here you have such a chart about patent classes, and the yellow line is the average of all the found 1,000 similar patents, and the blue one is are the patent classes of the more relevant patents, and especially of the starting point of the whole thing. And here on the lower right you have this similarity curve, where you see that at first you have a rather quick descent, and later on it only gets less similar slowly. So we have, for instance, here now, by having started with this one patent, we have a list of 1,000 most similar patents, and the method of choice here is to have a look at these patents and to find out which of them is quite similar to what you are looking for. For instance, here you have these classification maps. This is what I mentioned before, that you have, for instance, in the upper left corner, the top IPC codes. You have this similarity average in black, and here you have the CPC codes. And the most interesting IPC codes, the most interesting IPC codes are those which are more relevant than the similarity average. It is even better depicted down here with the top cooperative patent classification with the CPC codes. Here, for instance, you see 2 CPC codes which are far above the similarity average, and this means they are quite specific for the technology we are looking for. And on the right you also have IPC codes or CPC codes below over time. where you see which IPC codes and CPC codes are relevant here over time, and that there is a certain change um, which is concurrent to the development of the technology. Now, going back again to this example, having started with this German patent application with the title Plasma Coating Method for Depositing a Functional Layer and Depositing Device of the applicant Sura Instruments and Plasma Innovations, uh, you see again here in the top IPC codes that you have some classes which are far more important than the similarity than in the similarity average. Uh, so those classes are obviously appearing in the more specific patents which are more relevant for the technology. And so one can interactively choose such an international patent class here, for instance. And this is the class, in this case, C23, C16, 509. And one can enter this now in the filter. So we have chosen this button filters, and we can enter here the IPC class which shall at least appear. So we are now looking only for patents where this patent class is at least one of the classes which appears or which is given by the examiners. So with using this filter of the already quite specific patent class, which clearly can also be checked before you use it, looking at it, what is this patent class all about. But it is very helpful that you have got a proposal or indication by the interactive graphics that this patent class is of special importance. So having used this filter of the IPC class, you have here a list of 108 most similar patents. And the next step can be that, okay, in this case, we have taken not this very detailed subclass, but we have taken C23, C16. Before we had the subclass 509 then, but now we just restricted to C23, C16, and we additionally use the filters that the words atmospheric and plasma have to occur in the patent, and that the words CVD and PVD are exclusion criteria. So if they appear in somewhere in the title or abstract or claims, these patents are not indicated or are not in the result list anymore. So having used these filters, we now arrive at these 108 most similar patents, and again, the next step may well be that we take a look at the patents and see which of them is best in the best proximity of what we are looking for. There may be another approach, or this can be a result of before, or in this case this has been a result of the step before, that we have identified now 3 patents. So one we already had, the German patent application, but now we identified also a US granted patent and a world patent application, which are very relevant. We enter these three patent numbers separated by commas, and we arrive again at the list of 1,000 similar patents. And the next, so here it is shown a bit in more detail. Again, we have these three numbers. We have the filter settings as we had before. And by searching now on it, we have only, let's say, only 349 most similar patents. So the default value, if there are very many similar patents, the default value is always 1,000, and this 349 already means we have not found more than 349 patents which fulfill all the criteria we have set up here. So again, the next step will be to have a look at the most similar patents and to choose some of them. This can also be done by looking at the similarity density curve on the right side and to cut off at a certain similarity. For instance, in this case, which is depicted here, we have made a cut off at the 20 most similar patents, so not more than 20 most similar patents. Here you have also on the upper left side a depiction of the certain countries or patent offices, authorities of the authorities. So in green, the most of them are world applications or PCT applications. The next is Japanese patents or patent applications, German ones, Korean ones, then European patent applications and US patent applications. So you see that there is a bit of a stronger hold or a stronger position of Asian countries, although in this technology China is not that important already. So another way can be that you take the filter settings and that you enter here a value. For instance, in this case, we take the 50 most similar patents by entering 50 here in the one line, and here we then can have a look at the basic charts. You see here that there are several charts which you can generate, and here we have used the option of generating basic charts. The other thing is about classification, where you see different graphics about classification, and then you have feature competition, where you get graphs about competition, but also cooperation between different patent applicants. And then you can have a more detailed patent analytics and also a trend of the landscape. Here in this case, you have a depiction of the top applicants. Clearly most of them are the other applicants, but the single most important applicant in this case is Fraunhofer Gesellschaft, and here you have a depiction on the right of technological areas and fields. So this is basically a summary of or a naming of certain patent classes with a general title. So, for instance, chemistry, electrical engineering, and mechanical engineering. One could also depict more specific patent classes. Here below, you have a timeline of so a technology timeline, and here below you would have other fields still. Um, so for instance, this is again this picture with the 50 most similar patents. Um, Here you have the list, here you have the similarity density curve to the right, and here you have again the different authorities. Um, from that you get an impression of where is this technology mostly patented. Uh, some indication is also then where has it been invented, although this is not a convincing argument, but most of the time, if you have here so many Japanese patents, uh, there is a high probability that it has been invented in Japan. If you want to know it better, you can later on look at the patents and see where the priority application came from, or uh, which home country an applicant has. Uh, Here we have chosen the graphics for classification. Before we had the graphics for basic, so the basic graphics, and here we have chosen the graphics for classification. And you see again here, you have these top IPC codes, you have a similarity average, and you have, for instance, here a class which is uh, significantly more important than in the similarity average. Or also here in the CPC codes, you have this one code which is very prominent here, something like C22, or was it C23, C16. Here you have this one, for instance. A very interesting possibility is also to use the patent analytics graphics, where you can, for instance, look at the market coverage those patents have, or on the upper right on the technological broadness indication. So here it is only one technology field where the patent is relevant or applied, and here it's already four technology fields where this patent is relevant, and clearly the value of a patent is higher the more technology areas it influences. Here you have graphics of patent impact and risk grid. Um, Here you have again a patent quality indication. Um, Very important is also this feature, this graphic below, in the lower left corner, quantity of citations and references. To the left are the references, to the right are the citations, and in the uppermost line we are talking already about more than 50 citations for patents, which is a very high number and shows that these 6 patents are very much cited and can be considered as very important patents in this technology field. So here it is. Here we have zoomed into this thing. So, and we can interactively choose these 6 most cited patents. They are indicated here below, and the most cited patent is from Fraunhofer Gesellschaft with this IPC C23C, atmospheric pressure plasma deposition for adhesion promoting, corrosion protective, surface energy modification, or mechanical, electrical, or optical layers. So this is obviously a very important patent which has a priority date back in 1998. So we can say that this is at maximum valid till early next year, the 20 years, but it has in the meantime had a lot of impact on other developments. Another possibility with the patent analytics graphics is to look at the market coverage. So here you also have this depiction of patents which are only relevant in one market, up to patents which are relevant in 6 to 10 markets. And here, so this in fact means how high the internationalization, the international applications are. If you have here this box, it has been the patent family is between 6 and 10 different countries. On the other hand, here you have a technological broadness indication, which can also be important. If you then take the last option, or the last button with trend landscape, you get charts called the Optimine Analytic Radar, where you have graphical depiction of the qualitative value of a patent. For instance, you see here the technology average is in blue here, and the patent universe average is here, and therefore you can see how this field is performing in regard to number of references or number of citations. It has not the high broadness, it has not the high claims quality indication. At least the patent universe average has a high recency, so a lot of very actual patents, and so on. And here on the right you have a depiction of collaboration and competition. So the black one is the competition, but you see that especially in times where the technology has developed very fast with a lot of applications, you also see increasing collaboration between companies here in blue. And now I would like to show the citation search. So we have taken this one Fraunhofer patent, which is most cited, and if you take the level 2 here, direct and indirect citations, it's almost a universe of patents all around here. So this makes it rather difficult to get information from that, although you could look at each of the patents in detail. But there is another option which is very helpful here. You can look only at the level 1 direct citations. So those patents which have themselves cited the Fraunhofer patent. And here you get a bit of a better overview on these citations. If we look at it, even if we zoom in a bit, we can choose one of them, and we can then see the title, the patent classes, the applicant's priority date and publication date, and we can do this for each of these points interactively. There are other useful charts for interpretation of the citation search which are shown here. For instance, here we have a depiction how many citations and how many references we have. Here in the citation phase we see when the citations have been made or done. For most of them, more than half of them in the search report, then next fifth or so in the international search report, and about 1/4 or so in applicant reference or in applicant citation. Here you have a depiction of the different citation types. You see, partly the type is not defined, or for more than half, for 2/3 something, the type is not defined. But here you have those types which are relevant and critical in search reports, like the X for novelty destroying documents, the Y for documents showing that the inventive step or the inventive character is not high, and so on. And here you have a depiction or a comparison patent and non-patent literature, and you see that the overwhelming majority is patent literature, but you have some non-patent literature contained here. Further useful charts for interpretation of the citation search are again here the top applicants. We have already seen that Fraunhofer is here in a front runner. We have here a technology timeline which shows that you had on average 2 to 3 patents over the years here, with a very strong year then around 2008, but in the last couple of years, except this one year, we had less patents seen. Here you have a depiction of the top IPC codes, so you see which specific subclasses are relevant here, and on the other hand, here you have the same thing for the CPC codes. Here you also have a detailed information about the citations and non-patent literature. So also for the citation search, you get such lists. Here we have 49 publications, and on this page you have depicted the results 1 to 25, which are mostly of the type citation, but partly also of the type reference here. And down here you have 2 examples of non-patent literature, which you could also try to retrieve, but very often this non-patent literature is quite costly to get in full content. Sometimes you get abstracts for free, and sometimes companies or even more universities have already access to some of these providers of non-patent literature, but otherwise it can get very costly. So this sums up my presentation of the topic semantic search and artificial intelligence ordering and interactive graphics, which is a general guide I have provided, but exemplified here with examples from a certain customer support action, from a one-to-one support action of this year, and using Optimine as the software of choice. And this this software Optimine, according to at least an informal agreement we have with the CEO of Optimine, can be used by partners of the VIP4SME project, at least for very good conditions, in some cases also at least for a certain period of time, also free of charge, to get a good overview and to decide whether one is then afterwards interested in making an agreement with Optimine. But the first couple of weeks can be a free service, and organizations interested in that should please contact me, Udo Gennari at Business Upper Austria, for getting such an agreement done. Thanks a lot for your listening, and I am open to questions on that, which will be probably be possible to be put on a certain Q&A forum, and I will then answer the questions. Thanks a lot.